Welcome to Learn Yourself. Today we are going to understand and learn the question answer from the final exercise of chapter Gravitation. The first question is, how does the force of gravitation between two objects change when the distance between them is reduced to half? So we have to see that how much gravitational force will change when we are reducing the distance to half. So let us first write the gravitational force formula, that F equals to G into capital M into small m divided by d square, which is a distance square. Now we have to reduce the distance to the half. So instead of d, we are taking d by 2. Instead of d, we are taking d by 2 because distance we are reducing it to half. So instead of d square, we are keeping the d by 2. So F equals to G into capital M into small m divided by d divided by 2's whole square, because we have reduced distance to half. Once we will solve this, we will get G capital M into small m divided by d square divided by 4. Now this 4 is in the denominator. So denominator will go to numerator. So we will get here G into capital M into small m divided by d square. Now in this formula we can see here, this is our original formula of force. So this is our force, gravitational force formula. So this is gravitational force into 4. So our force equals to force into 4. So that means that if we are reducing a distance to half, gravitational force will be 4 times more than that of the earlier force. So as distance is lesser, the gravitational force will be higher. So we have reduced distance to half, so gravitational force has been increased to 4 times. Our second question is, gravitational force acts on all the objects in proportion to their masses. Why then a heavy object does not fall faster than a lighter object or light object? So here we know that gravitational force is also depending upon mass. So whose mass is more, the gravitational force acting on that object will be higher. So when any object will fall, it will gain some acceleration, which will be due to gravity, and we know that this acceleration is known as acceleration due to gravity. This acceleration due to gravity does not depend upon mass. While object is falling, it will gain some acceleration, but that acceleration due to which it is falling, it is not depending upon mass, and because of that the heavy object will not fall faster than the lighter object. So both of this object will fall due to the acceleration, and acceleration is independent than that of the masses of the object. So that's why heavy object will not fall faster. Our next question is question number 3. It says that what is the magnitude of the gravitational force between the earth and a 1 kg object on its surface? So we have to find out the gravitational force. How much will be the gravitational force between the earth and an object? Object's mass is 1 kg and that is lying on the surface of the earth. Mass of the earth has been given to us and radius of the earth has been given to us. Now we know the formula, that F equals to capital G capital M into small m divided by d square. That means it's distance. Now distance here we are going to take is radius of the earth, because it is lying on the surface of the earth. So the distance between the earth's center and the object will be equal to the radius of the earth. Now let us note down what all things have been given to us. That mass of the object has been given to us, that is 1 kg. Earth mass have been given to us is 6 into 10 raised to 24 kg. Then radius of the earth, that d square. So r equals to d equals to 6.4 into 10 raised to 6 meter is the radius and the distance between two objects. Now let us put all the values over here, and gravitational constant G. G we are taking here 6.7 into 10 raised to minus 11. This will be the value of G, and that we have to remember. That G's value we are going to put it here. So G's value first we are going to write that 6.7 into 10 raised to minus 11 in multiplication with capital M, that is mass of the earth. So 6 into 10 raised to 24 into small m, that is 1 kg. So 1, that is a mass of the object, divided by radius of the earth and distance between two objects. So that is 6.4 into 10 raised to 6. Now this radius and the distance square is there as per the formula. Now once we are solving this, we will get here 6.7 into 6 divided by 6.4 into 6.4, because this is a whole square. Now let us solve this 10 to the powers. Now here minus 11 is there. We are adding this 10 raised to 24 into this. And here 10 raised to 12 is there, because 6 will be in multiplication with 2. So 10 raised to 12 is there into the denominator, that we are subtracting from above powers. So here minus 12 will be there. 6 multiplied by 2, so we will get 10 raised to 12, and that is in the denominator. Once we are taking it into the numerator, it will be in the subtraction. Once we will solve this term, we will get here 0.981. We will get this answer from this term. Now let us solve this. This is minus 11 plus 24 minus 12. So here we will get 10 raised to 1. As this is minus 23 plus 24, so we will get 10 raised to 1. So answer what we will get here is 9.81. And that too, this is a force. So this will be a Newton. The force equals to 9.81 Newton, and this much magnitude will be there for the gravitational force when 1 kg object will be lying on the surface of the earth. Our fourth question is, the earth and the moon are attracted to each other by gravitational force. Does earth attract the moon with a force that is greater or smaller or same as the force with which the moon attracts the earth? Why? So as per the universal law of gravitation, each and every object attracts the other object, and this force, the magnitude of force, will remain same. So here the earth and moon both attracts each other with the same force, but the direction will be opposite to each other. That earth attracts the moon towards itself and moon attracts the earth towards itself. So direction of this force will be opposite to each other. As per the universal law of gravitation, earth and moon both attracts each other with the same force, but the direction of the force will be in opposite to each other. So the force will be same. It is not greater or lesser than each other. It will be the same, but the direction will be opposite. Our fifth question is, if the moon attracts the earth, why does the earth not move towards the moon? In earlier question we have discussed that earth and moon both attracts each other with the same force of gravitation. Then why can't moon attracts the earth and earth is not taking a revolution around the moon? So the answer is, moon attracts the earth with the same force of gravitation as earth attracts the moon. That is true. But the mass of the earth is much larger than the moon. So the effect of earth's gravitational force we can see in terms of revolution of moon around the earth. But the other end, moon is so small and the mass of the moon is much lesser than the earth. So whatever effect the moon's gravitational force is generating, that is very negligible, and as a result we cannot see it. But the effect is also there and the gravitational force is also there, but the thing is we cannot see it. So how we can write it? That but the mass of the earth is much larger than that of the moon. So the effect of earth's gravitational force we can see in the revolution of the moon around the earth, whereas effect of moon's gravitational force is negligible and we cannot see it. So that doesn't mean the effect of gravitational force of the moon is not there. It is there, but it is negligible and we cannot see it. Our sixth question is, what happens to the force between two objects if the mass of one object is doubled? So here we have to discuss three different cases. This is the first case in which the mass of the one of the object we are making it double. So what will happen to the force which is acting between them? So let us calculate that. Our original equation and formula is F equals to capital G, capital M into small m divided by R square or D square. Here we are taking R, that is a radius of the earth. Now the mass of the one of the object is doubled. So any one mass you can make it double. So here we are taking m equals to 2m we are taking and we are making it double. 2 into m we are taking. So let us take this value into this equation. So we will get here G 2 capital M into m divided by R square. Once we are taking this 2 to the front, so we will get G into capital M small m divided by R square. So here this formula is our original gravitational force formula. So here I am going to write F equals to. So here we are going to get 2 into F. So as a result, when we are making one of the object's mass double, our force will also doubled here when we are making one of the mass of the object doubled. So the force is directly proportional to the mass of the object. The second question is, the distance between the objects is double and triple. So in first case we are making the distance double. So our force is F equals to G into capital M into small m divided by D square, where D is the distance between two objects. In first case we are making this distance double. So here we are taking D equals to 2D. Why? Because we are making the distance double, so 2 into distance. So this value we are putting into this equation. So we are getting here G capital M into small m, and instead of D we are taking 2D and then 2 square. So we will get here capital G capital M small m divided by 2 square is 4 and then D square. So let us take this 4 out. So 1 divided by 4 into G capital M and small m divided by D square. Now this equation represents the force acting between two objects. So we can write here that 1 divided by 4 into F. So force has become 1/4 here. Earlier the force was this and now the force has become 1/4. So as we are increasing the distance, and specifically when we are making the distance double, our fourth will be reduced by 1/4. Now in second case we are making this distance triple. So D equals to, we are taking 3 into D because we are making the distance triple. So now let us put this value into this equation. We will get G capital M small m, and instead of D we are taking 3D. So 3D square. So we will get here 3 square is 9 into d square. So let us take out this 9 out. We will get 1 divided by 9 into g, and the same equation of the force. This is the same equation of the force. So I can write here 1 divided by 9 into F. So when we are increasing the distance between two objects and we are making it triple, at that time force will be reduced to 1/9. Third question is when mass of the both objects is doubled. So our force equals to G capital M into small m divided by d square. Now we are making both objects mass double. So m equals to we are taking 2m and small m equals to we are taking 2 into small m. So let us put both the values over here. We will get G 2 capital M into 2 small m. Instead of m and small m, we have written here 2 at front of both because we have doubleized the mass of these two objects, divided by d square, the distance between these two objects. So G, this 2 and 2 we can multiply. So we will get here 4 capital M small m divided by d square. Let us take out this 4. So we will get 4 G capital M small m divided by d square. So this is our force. This is the formula of our force. So we can write here 4 into force. So when we are doubleize the mass of both of this object, our force will be 4 times higher than that of the older one. Our seventh question is, what is the importance of universal law of gravitation? That means where and all this universal law of gravitation is helping us. So it connects us to the earth. Because of that, our ecosystem, the whole ecosystem is surviving and we can stay on the earth. Second, because of the earth gravitational force, the moon revolves around the earth and it is responsible for the moon's revolution. Then motion of the planets around the sun. So the whole solar system is existing because of the gravitational force. Then tides are due to the sun and moon's gravitational force. So here are some of the important application of gravitational force. Our eighth question is, what is the acceleration of free fall? First of all, what is a free fall? So any object is falling under the gravitational force alone. For example, we are dropping something. That is a free fall because there is no external unbalanced force acting on it and that object is falling due to the gravitational force of the earth. Earth is pulling that object towards itself and that's why it is falling towards the earth. For example, apple is falling from the tree. It will go towards the earth because gravitational force acts towards the downward. So that is a free fall in which the object is falling only and only due to the gravity. Now when object is falling down, certain acceleration will be associated to that, and that acceleration is also a product of this gravitational force under which this object is falling towards the earth. So this acceleration is known as acceleration due to gravity because it is not under the impact of any other force. It is under the impact of gravitational force. So that acceleration is termed as acceleration due to gravity and it will be always associated with a free falling object. Any object falls towards the earth due to gravitational force of the earth alone and without another force acting on it, that is very important, is called a free fall. The acceleration produced during the free fall is due to the earth gravitational force and it is known as acceleration due to gravity. Our ninth question is, what do we call the gravitational force between the earth and the object? So gravitational force which is acting between the earth and the object will give us the weight of an object. Weight of the object is a result of Earth's gravitational force to the object. Our 10th question is, Amit buys few gram of gold at poles as per the instruction of one of his friends. He hands over the same when he meets him at equator. Will the friend agree with the weight of the gold bought? If not, why? We know that acceleration due to gravity at the poles are much higher than compared to the equator, because our Earth is not a complete sphere. So where the acceleration due to gravity is more, the weight will be more, and where the acceleration due to gravity is less, the weight will be less. So whatever Amit buys at the poles, the weight will be according to what his friends will say. But once he reaches till equator, the weight of the gold will be less, and that is due to the acceleration due to gravity is less compared to poles. So acceleration due to gravity is more at poles, so weight will be more at poles, but it is less at equator. So weight of gold will be less at equator. So Amit has bought the gold of certain weight at some price. When he reaches till equator, the price will remain same, but weight of the gold will be less. So his friend will not agree to buy that because the weight will be less compared to what he was expecting. Our 11th question is, why will a sheet of paper fall slower than one that is crumpled into a ball? So you are making a ball of paper and one plain sheet of paper, you are making it fall from certain height, and you will observe that the sheet of paper is coming slower than that of the crumpled ball. When any object is falling, it will face a resistance from the air. So that resistance will be directly applicable and directly proportional to the area of the object. Now, the sheet of paper having a larger area, it will face a more resistance from the air, whereas a crumpled paper, which is a ball type, that will face a lesser resistance because of its lesser area. So air resistance will be applicable to both of this object as they will fall down. Sheet of paper will face more air resistance because its area is more compared to crumpled paper. So it will fall slower than the crumpled paper. Question number 12. Gravitational force on the surface on the moon is only 1/6 as strong as gravitational force on the earth. What is the weight in newtons of 10 kg object on the moon and on the earth? So here what they have given us is 10 kg, and that is a mass. We have to find out this object's weight in Newton. We have to find out weight in Newton, and whatever they have given is a mass. So first we are going to find out the weight on the earth, and then we are going to find out weight on the moon. So weight on the earth equals to, that is W, E equals to m into gravitational force. So m is going to be 10 kg. So here 10, and g's value is 9.8. So our answer is 98, and that to Newton. That to Newton. Kg, meter per second square. So that is Newton. So weight is into the Newton, and this much weight is there on the earth. Now we are finding the weight on the moon. We know that weight on the moon equals to, here also they have written that gravitational force on the surface of the moon is only 1/6 as strong as gravitational force on the earth. So weight on the moon equals to 1/6 into weight on the earth. So we know that how much weight is there on the earth, that is 98 Newton. So 1/6 into 98, So once we will divide this, we will get here 16.33 and that to Newton. So this much weight will be there on the moon. For this object, this much weight will be there on the moon and this much weight will be there on the earth. Here weight is less because gravitational force of the moon is less. Here weight is more because gravitational force of the earth is more. Our 13th question is, a ball is thrown vertically upward with a velocity of 49 meter per second. So one ball is there and we are throwing it upward, and this velocity, with which velocity we are throwing it upward, is 49 meter per second. So it is going to be 49 meter per second, and with this velocity we are throwing it upward. That means this is initial velocity. With this much velocity we are throwing it upward, so this is initial velocity. Now once the ball will reach at maximum height, it comes back, and for the fraction of second it is going to stop there, so that will become its final velocity. And whenever we are throwing any object towards upward, in that situation we are giving some of the velocity. So in that case it has some of the initial velocity, but it will stop at one point and then it will come back. So that's why its final velocity is always going to be 0. So here final velocity is 0 and initial velocity is 49 meter per second. Now we have to calculate the maximum height to which it rises. So how much distance it will travel. So S equals to what? That we have to find out, that how much distance it will travel if we are throwing it upward with 49 meter per second velocity. Then total time takes to return to the surface of the earth. Now here they are asking us to calculate a time, and that to return to the surface of the earth. Always we are calculating this much time, that it is reaching till the top. That much time we are calculating. Here we have to calculate the timings by which it is reaching till the top and then again it comes back to the earth. So return to the surface of the earth, that also we have to find out. So that means whatever time we will get here, that time we will multiply with 2, or the same time we will add it one more time, so we will get this time. So here this is little bit different compared to earlier example. Till now whatever examples we have seen in chapter 8 and 9, in that we were calculating this much time and this much distance. But here in this case we have to find out that how much time it will take to return to the surface. So once it will go up, that time, and again it comes back, so that time. So 2 times this time we have to calculate here. Let us see how we are going to do this. We know that what all things have been given to us, that final velocity is 0 here, initial velocity is 49 meter per second. We have to find out the distance and we have to find out the time. Our first equation through which we are going to find out the distance is v square minus u square equals to 2as. V square is going to be 0, u square is 49 square equals to 2 into a into s. Now a is here acceleration due to gravity. So that is going to be a equals to g, and here this is going to be minus 9.8 because this is against the gravity. Anything which is falling towards the earth, that will get acceleration 9.8, that is positive. But this is against the gravity, so this is going to be minus 9.8. So here a we are going to take, that is 9.8, and that to minus 9.8. 49 square, so we are going to get here 2490, that is 49 into 49, and minus will be there as this sign we are keeping it here. So here we are going to get 2 into minus 9.8 into s. So s equals to 2490 divided by this 2 term, we are getting it here into the denominator. 2 into 9.8. Now both the side the negative sign is there. So we are cancelling out the negative sign from both the side. So this term is going to be positive here. So we will get answer once we will solve this. 122.5 meter will be the answer from this term, and this is our first answer, and that is the distance. So how much distance it will cover once it will reach the top? 122 meter, 122 meter distance it will travel when it will reaches till the top. Now we have to find out the time. Now for the time, we know that V equals to U plus AT. So V is 0, U equals to, we know that it is 49. So 49 plus A, we know that it is minus 9.8, and T we are going to find out. So this 49 we are taking towards this side. So it is going to be minus 49 equals to minus 9.8 into T. 9.8 will go to the denominator of this. So 49 divided by 9.8 equals to T. Now both side the negative sign is there. So this term is going to be positive. Once we will divide this, we will get T equals to 5 seconds. So time is 5 seconds. But this time is when ball is reaching till the top. This time is 5 seconds. So 5 second time ball will take to reach till the top. Again it comes back in the same time. So again it will take 5 seconds more to reach till the earth surface. So we are going to multiply with 2. 2 into 5 seconds equals to 10 second time it will take to return to the surface of the earth. Our 14th question is, a stone is released from the top of a tower of height 19.6 meter. Calculate its final velocity just before touching the ground. So here stone is there and we are dropping from certain height, and that height is 19.6 meter. So it is traveling this much distance while it is coming down. Now we have to find out that its final velocity. So when it is falling down, what is going to be its final velocity? We are dropping it without any external force, so its initial velocity is going to be 0. Its velocity will increase as it comes down. And under this situation, it will gain some acceleration. That acceleration is going to be the acceleration due to gravity, and that is 9.8. Here 9.8 we are taking positive because it is towards the earth and it is towards the force direction. So this 9.8 meter per second square will be positive in this case. Now let us note down what all things have been given to us. That height is 19.6, that means it is traveling this much distance. So S equals to 19.6 meter. Its initial velocity is going to be 0 because we are just dropping it. Its final velocity we have to find out. So we are going to use this equation, v square minus u square equals to 2as. So v square that we need to find out, minus u square is going to be 0 equals to 2 into a. So a equals to g equals to 9.8 we are going to take. 9.8 meter per second square. So it is 9.8, and distance we know that it is 19.6. So v square equals to, now here when we will multiply 2 into 9.8 we will get 19.6. So 19.6 into 19.6. So here this is 19.6 square equals to v square. When we are taking both the sides square root, we will get v equals to 19.6 meter per second. So this much final velocity it will gain just before touching the ground. Fifteenth question is, a stone is thrown vertically upward with initial velocity of 40 meter per second. Taking g equals to 10 meter per second square, find the maximum height reached by the stone. So one stone, we are throwing it upward, and that too they have said that this much is the initial velocity. So u equals to 40 meter per second velocity we are taking. Then g equals to, we are taking 10 meter per second square, and this is in opposite direction of the gravitational force. So this 10 is going to be negative. This 10 is going to be negative. We have to find out that maximum height reached by the stone. So how much distance it will cover, that we have to find out. Height equals to distance. So how much distance it will cover by reaching till the top, that we have to find out. And what is the net displacement and total distance covered by the stone. So once it will go up and it will stop at one point and again it will come back. So at that point its final velocity is going to be 0, and after that it will start coming back. From there it will start coming back. So how much total distance it will cover once it is going up? So this path, that is A while going up, and B while going down. So total distance if we want to see, then it is going to be A plus B while going till the top and coming down. So total distance is going to be A and B. So we are going to find out here total distance, and then we are going to multiply it with 2. So the total, how much distance it will cover by reaching till the top and then again coming back, that we can calculate through that. Now net displacement. So once we will find out this, we will discuss about the displacement. So let us find out first how much distance it is covering when it is reaching till the top. So let us note down what all things we have. U equals to 40 meter per second. V equals to, we will get here 0. When it is reaching till the top, its final velocity is 0. S, we have to find out that how much distance it will cover, and G, as they said, we are going to take 10, and that too minus because it is going against the gravitational force. Now let us write equation that V square minus U square equals to 2AS. Now A we are taking equals to G because that is acceleration due to gravity. So V is going to be 0 minus 40 square equals to 2 into minus 10 into S. So 40 square is 1600, and that to minus, here we are going to get minus 20 into S. S equals to, we will get 1600 divided by 20, and this term is going to be positive because both side negative sign is there. So we will get here 80. Now S equals to 80 meter. That much distance it will travel when it will reach till the top. So when it comes back, so how much distance it will travel total? So total distance equals to 80 plus 80. So equals to 160 meter it will travel. When it is going up and down, it is traveling total 160 meter. Now about net displacement. Now what is the meaning of displacement? Displacement means the object has started the journey from the point, that is initial point, and then it comes back, and when its journey ends, that will be the final point. But here the initial point and final point are same. So whatever displacement is there, that is a 0. We have already learned this in chapter 8, that in this situation, when the object's starting point and ending point is same, in that case the total displacement is going to be 0. So here also, from where we are throwing the stone, it comes back to the same place, original place. So here net displacement is going to be 0 to 0 because its starting point and final point is same. So that's why net displacement is 0, whereas the total distance covered by the object is 160 meter. 16th question is, calculate the force of gravitation between the earth and the sun given that the mass of the earth is this much and that of the sun is this much, the average distance between the two is this much. So we know that the formula through which we can find out the gravitational force between two objects is F equals to capital G m into m. So this is the mass of both of this object divided by the distance between two objects. So here all the things we know, that both the objects mass we have, then distance also we have. Now G equals to, we are going to take, that is 6.7 into 10 raised to minus 11, that is gravitational constant as per the universal law of gravitation. So let us put all the values here. So first is G, that is 6.7 into 10 raised to minus 11 into capital M. Capital M we are taking earth, 6 into 10 raised to 24. Small m we are taking sun's mass, that is 2 into 10 raised to 30, divided by the distance between these two, 1.5 into 10 raised to 11, and this is square, d square. So we are going to write here another time this term, because that is d square, so d into d. Now let us solve this. First let us solve the power of 10. So that is 6.7 into 6 into 2 divided by 1.5 into 1.5 in multiplication with 10 raised to minus 11 plus 24 plus 30. Now in the denominator 10 raised to 11, 10 raised to 11 is there. So if we are taking it into the numerator, it is going to be negative. So negative 11 and one more negative 11, minus 11 and minus 11. Now once we will solve this, we will get here minus 11 and minus 11. So we will get here 10 raised to minus 33. And when we are adding this to 24 and 30, we are getting here 4 and 2 plus 3 is 5. So 30 minus 33 plus 54, that will be the power of 10. And when we will solve this term, 35.73, this is the answer of this full term. So 35.73 into 10 raised to, this is going to be there. Now in next we need to subtract this because one of the term is negative, so it is going to be 21, but the sign what we will get is positive because the bigger number is carrying positive sign. So this is going to be the answer, that gravitational force between the earth and sun is 35.73 into 10 raised to 21. So this much gravitational force will be applicable to the earth and sun. Question number 17. A stone is allowed to fall from the top of a tower that is 100 meters high, and at the same time another stone is projected vertically upward from the ground. So two stones are there, one that is falling from the top and one stone we are sending it upward or we are throwing it upward. So two different stones are there and this height is 100 meter. This height total is 100 meter. This tower is 100 meter. And the stone which we are throwing upward from the ground with a velocity of 25 meter per second. So here initial velocity of this stone 2. This is a stone 1 which is falling on the ground, and this is which we are throwing it upward. Its velocity, initial velocity is 25 meter per second. Now calculate when and where the two stones will meet. So when we are throwing both of the stone in same direction, so where they will collide with each other, at what point, at what distance, at what time, that we have to find out here. The only thing we have, that is 100 meter distance, that they are going to meet somewhere in between this 100 meter distance, and the initial velocity of this second stone. So this is the stone 1 which we are dropping from the top, and this is the stone 2 which we are throwing it upward. So both directions are opposite to each other. Now let us calculate for the stone 1 that stone 1, the initial velocity for stone 1 is going to be 0 because we are dropping it. Then final velocity we do not know that how much it will have a final velocity. Then so distance it will cover is 100 meter. Now G, in case of the stone 1 which we are dropping it, it is going to be 9.8 and it is towards the earth, it is in the direction of the motion, so this is going to be positive. Now let us find out first the distance for the stone 1. So S1 equals to ut plus 1/2 at square. Now time we do not know that how much time it will take to meet the second stone, so we are going to keep this time as t only. So here u is going to be 0, so this term will be 0 because u is 0, so this term is 0. We will get here 1/2. A we are going to take 9.8 and t we do not know that it is t square. So this is for the stone 1 that we are dropping it from the top, that half 9.8 t square. So S1 we are going to get 4.9 t square. Once we will divide this 2 with 9.8, we will get 4.9. Got S1 that is 4.9. Now for the stone 2, we are going to find out the same thing for the stone 2. Now stone 2 we are throwing it upward, so it has initial velocity that is 25 meter per second. Final velocity is going to be 0. Distance we know that it is going to cover 100 meter distance, but we need to find out that, and gravitational force we are going to take is 9.8, but that will be minus in this term because we are throwing it upward and that will be against the motion. So this 9.8 is going to be minus for the second stone. So similarly, as explained, when we are taking the distance for the stone 2 is equals to S equals to ut plus 1/2 at square. Here they have given 25 meter per second. So 25 into t plus 1/2, and this is going to be minus 9.8 t square because this is in opposite direction as explained and it is against the acceleration due to gravity. So this A's value and G's value is coming here negative. So here we are going to get 25t minus 1/2 into 9.8 t square. So 25t minus we will get the same, that 4.9 t square. So this we are getting it for the S2, that is stone 2. This equation we are getting, and for the stone 1 this equation we are getting. Now we know that for both the stone S1 and S2 the total distance is 100 meter. So we are adding this S1 plus S2 and we are writing equals to 100. Now when we are substituting S1 value and S2 value in S1 plus S2 equals to 100 meter, we will get this. Now you can see here 4.9 t square and 4.9 t square both are having opposite sign. So we can cancel out this two term. So we will get here 25t equals to 100 meter. So t equals to, we will get 100 divided by 25. So t equals to, we will get 4 seconds. So here we got a time. So that t's value we are going to put in this two separate equation, that S1 equals to and S2 equals to. So we will get a timings for the stone 1 and stone 2, that for that particular distance how much time they are covering. Now in this two equation we are going to put this value, that t equals to, we know that it is 4 seconds. So equals to 4.9 into 4 square. So 4.9 into 16 we will get here. So S1. This value we have put in this S1. So S1 equals to, get here 78.4 meter. So distance for the first stone is 78.4 meter. The same thing, we are substituting t equals to 4 second in this equation. So we will get 25 into 4 minus 4.9 in multiplication with 4 square. So here 100 minus, we will get 4.9 into 16. So we got here 78.4. And when we will subtract this, we will get S2 equals to 21.6 meter. So to tally the answer, we can just add 78.4 plus 21.6. So we should get 100 meter. So yes, when we are adding this two distance, we are getting 100 meters. This much distance both the stones are covering. Now when one stone, we are dropping it from the top. So it is covering 78.4 meter distance, and the stone which we are throwing it upward, that is covering 21.6 meter distance. And they are meeting in between when the first stone has already covered 78.4 meter distance and second stone has covered 21.6 meter distance. The time when the both stone will collide with each other, that time will be 4 seconds. That time will be 4 seconds. Our 18th question is, a ball thrown up vertically returns to the thrower after 6 seconds. So we are throwing one ball upward and it comes back to the thrower in 6 seconds. So this total time for the path A and B is 6 seconds. So if we want to find out the time for when the ball is going up, then we have to divide this total time by 2. Then only we will get the time when the ball will reaches till the top. So that time is 6 divided by 2. So time for the A path is 3 seconds. When the ball reaches till the top, it is 3 seconds. In this much time frame, it will reaches till the top. Now we have to find out 3 things. First thing is the velocity with which it was thrown up. So here 2 velocities will be there. When it is going up, that velocity is going to be u, and that we have to find out. Initial velocity we have to find out. But once it is reaching till the top, its final velocity is going to be 0. So in this case, u we have to find out and a is going to be 0. Now acceleration is going to be equals to the gravity, and that is against the gravitational force. So it is going to be negative. So minus 9.8 meter per second square we are going to take here. Now let us write down the equation from which we are going to find out the initial velocity. So for the A, it is going to be v equals to 0, u we have to find out, g equals to minus 9.8, and time for the path A is going to be 3 seconds. Because this is a total time, when ball again comes back to the thrower's hand, we have to calculate till here when it is reaching till the top. So for that, timings are 6 divided by 2, so that is 3 seconds. So here we are going to use the equation that v equals to u plus at. Now v is 0, u we need to find out, and at is minus 9.8 into 3. So u equals to, when u is going towards this side, it is going to be negative, and minus 9.8 into 3. When we will multiply this, we will get 29.4. So from both the side we are cancelling out negative sign. So u equals to 29.4 meter per second. So this is going to be the initial velocity for the ball. So this is our first answer. Now we have to find out the second answer, that maximum height it will reaches. So when we are throwing it upward, so that path we are taking it, and we are going to find out the distance. So for the B, we are going to find out distance, that s equals to ut plus 1/2 at square. Now initial velocity we know that it is 29.4, time we know that it is 3, then plus we are going to write 1/2 into minus 9.8 into time is 3 and that too square. So once we will solve this, we will get here 88.2 plus we will get here 1/2 minus 9.8 into 9. 3 into 3 is 9. 44.1 meter distance. So when ball is thrown upward, it is going to cover this much distance till the top and then it will start coming back. The third thing we have to find out is its position after 4 seconds we have to find out. So how much distance it will cover after 4 seconds that we have to find out. So ball we are throwing it upward and it will reaches till the top and it will start coming back. So in this journey, while it is going upward, it is taking time that is 3 seconds. Now they are asking to find the position at 4th second. So at 4th second, it has just started to come down. So this is a 4th second when it will be here just above the midpoint. Then at 5th second, it will be somewhere in the middle, and at 6th second, it will be down in the hand of the thrower. Right? So 6th second, at 6th second, ball's journey is going to be over. But at the 4th second, it will be somewhere above the midpoint. So this distance we have to find out, that at 4th second where will it be. So when we are finding out for this situation, so actually it has started traveling back and it has only take 1 second after that. This is 4th second for the entire journey. But when it started coming back, after its initial velocity is going to be 0. Because here we are evaluating this situation when it started coming back. So for this journey that it is started coming back, its initial velocity is going to be 0. So here initial velocity is 0 and at 4th second it will be its 1st second that it has just started coming back. We are not talking about the entire journey. We are talking only about this patch when ball has started to come back. So this 4th second is going to be the 1st second for the ball when it has started coming down. And for this situation, its initial velocity is going to be 0. Because it will reach till the top, it will stop there and then coming back. So this is going to be 0. Now when it is coming back, its acceleration due to gravity is 9.8 meter per second square, and that will be positive because it is towards downward and it is in the direction of the motion. So this is going to be positive. Now we are going to find out that how much distance it will cover. So here let us note down what all things we have. That initial velocity will be 0, g equals to a equals to 9.8, that will be positive. Time we are taking here, that is 1 second, because for this journey it has traveled only 1 second. How much distance it will cover within this 1 second, that we have to find out. So our equation is s equals to ut plus 1/2 at square. Now u is 0, so 0 into time, that is 1, plus 1/2 into 9.8 into 1 square. So this term is going to be 0. We will get here half into 9.8. This is going to be 1. So 9.8 divided by 2. We will get here 4.9 meter. So this much distance the ball will cover in 1 second. That 4.9 meter. So we can write here as an answer that ball will cover 4.9 meter distance from the top. Or we can write here that at 4th second, ball will be at 4.9 meter from the top. 19th question is, in what direction does the buoyant force on an object immersed in a liquid act? That means they are asking us that in which direction the buoyant force will act. For example, this is a container liquid has been filled into that. This is an object which we have immersed into the liquid. So buoyant force will act towards upward. It is towards upward. So buoyant force direction is towards upward. So buoyant force will act in upward direction on object. 20th question. Why does a block of plastic released underwater come up to the surface of the water? So we are just dipping it inside, but it will bounce back and coming to the surface of the water. So when we are releasing a plastic block underwater, two forces will act upon it. First, that is gravitational pull, which pulling it downward. And second, the upthrust force of the liquid, which pushes it upward. Now here, the density of this block is lesser than that of the water. So upthrust force or the buoyant force which is acting upward will be higher and will be more compared to the gravitational force acting on the block. So as a result, the block will come to the surface and it will not remain immersed or it will not sink into the water, but it will come to the surface because here the buoyant force act on the block will be more compared to the gravitational force. Question number 21. The volume of 50 gram of a substance is 20 centimeter cube. If the density of water is 1 gram per centimeter cube, will the substance float or sink? We know that when substance density is less than the water, then it will float. And if the substance density is more compared to water, then it will sink. Here we will write object. If object density is more than water density, then in that case it will sink. And if the object's density is lesser than the water, then it will float on the surface. So first we have to find out the object or substance density. So how to find out density? So density equals to mass divided by volume. This is a formula for the density. Now mass, we know that it is 50 gram. 50 gram and volume they have said is 20 centimeter cube. So we will get here 5 divided by 2. So we will get 2.5 gram per centimeter cube. So this is a density of substance or an object. Now we need to compare this with water. So density of substance is this. This much is the density of the substance. Now density of water. Equals to 1 gram per centimeter cube. That is a density of water. Clearly that water's density is lesser than that of the density of the substance. So when object's density is more compared to water, then it will sink. So here we are going to write that. Here question number 22. The volume of 500 gram sealed packet is 350 centimeter cube. Will the packet float or sink in the water if the density of water is 1 gram per centimeter cube? What will be the mass of water displaced by this packet? So here we have to compare the density, because if the packet's density is more compared to water, then it will sink. And if the packet's density is lesser compared to water, then it will float. So here we know that packet's density is lesser than that of the water's density, then it will float. And if packet's density is more compared to than that of the water's density, then it will sink. So first we have to find out the packet's density. Now what is the density's formula? density equals to mass divided by volume. So what is the mass here? That is 500 gram divided by volume has been given to us is 350 centimeter cube is the volume. So we will get here 50 divided by 35. So answer is 1.428 gram per centimeter cube is the density of the packet. So packet's density is this much. Now we have to compare this density with water's density. So this density is more, so packet will sink. That here, this is the answer, that packet's density is more compared to water, so it will sink in the water. Now next question is, what will be the mass of water will be displaced by the packet? For example, if this is a container and this much is the packet we have kept inside the water. So how much it will displace the water? How much ever the volume of this object is. This object's volume is this much. So that much water it will displace. So it will be equal to the volume of the packet. So here volume of the packet is 350 centimeter cube. So equally that much volume of water will be displaced by the packet. So here second answer is . So hope this video has solved your doubt. In coming videos we are going to cover some important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.